So continuing our analysis of circuit 2, the next thing we might be interested in is, well, what happens if we need to design it? Because it's all very well being analyse it with letters everywhere, but we need to know how we can analyse the circuit or design it for a particular value. So for the sake of argument, let's say that we've got a 10 volt supply, and we'd like a quiescent VC of let's say we wanted 6 volts. And we can make any other choices we want. The only thing we want is quiescent conditions of 6 volts. And the reason we might want that is if we drew a diagram, we could say, well, this will be Vs, which is 10, and we'll have to have some Vb, and there'll be some Ve. And this is magnitude of voltage up this axis, so this is volts. And this is, well, we can make it time if you like. And what we'd be saying is we need to pick some quiescent conditions somewhere around here maybe. We'll call it VCQ. And what we're saying is that VCQ is going to have to lay in some sensible range because we need to be able to swing our collector a decent range, and if we've got a different value there as we do to there, it will the smallest of these two will limit our swing, and that's undesirable. So we have the free choice essentially. We can choose what VB is going to be, we can choose what VE is going to be, we can get rid of VE completely by removing RE if we want to, but then the circuit wouldn't be the one I'm asking about, so we won't do that. The choices that you make, as long as they're sensible, are fine, and as long as you state all your assumptions, then you can't lose marks for any working that you might do, as long as it obeys your assumptions and is valid. So if we wanted, we've got 10 volts total, 6 volts there, so there is no particular order to what I'm doing. I'm working out as I go along. Something we can immediately say as well, there's going to be 4 volts there because VC plus VL has to add up to VS. So that's Kirchhoff's voltage law, if you like. The other thing we'll have to do is choose a value for this current, and we'll have to choose a value for this current. Or you could choose some resistors and then work out the currents and work out the voltages, but you then have to go and adjust your resistors to make your 6 volts go. So if we were to choose some currents, let's just say, for the sake of argument, that this is going to be, I don't know, 900 microamps, just say. And that we intend to arrange for an RE of 1.3 volts. And then we know we've got 0.7 volts there, because it's our VBE. So we know that VB is going to have to be that plus that, so it's going to be 2 volts. You might have got wind of the idea that I like VB being 2 volts. I can't remember the last time I set a question where it wasn't. Of course, this year could be the year. And if that's the case, well, we know what the voltage across R1 is going to be. It's going to have to be VC minus VB. So it's going to be 6 less 2, which is 4 volts. So actually, by making some choices about VE, we've made quite a lot of decisions about our circuit already. The other thing we need to do then is to say, well, you can either pick IL if you want, or you can pick IC. IC is, or rather, you already know what IC is because we're going to assume IB it doesn't exist at all. So we know that this is 900 microamps because I picked it down there. So the only thing we're left to do is figure out what this current I1 ought to be. And we can either make some choices about resistors and work back to find I1, or we can pick I1 and work out what our resistor should be. I'm going to pick the current. Now, I want R1 and R2 to be quite large, so I don't really want this current to be a significant fraction of this current, but I've got to make sure this current's big enough that the base current is negligible assumption will probably hold. So what I'm going to do is I'm going to make that 100 microamps, because that means that the total current here will be a milliamp. Alright, so already I can say, well, I know what RL is going to be. It's going to have to be 4 kiloohms, because I've got, if I apply Ohm's law to RL, I've got RL is VL upon IL, which is 4 volts upon 100 microamps plus 900 microamps, which is a milliamp, which is 4 k ohm. So I've got my 4 kiloohms. Let's try and do it black. Got my 4k there. Then I can say, well, same goes for R1. I've got 4 volts across it and 100 microamps through it, so R1 is equal to VR1 upon what we would call I1. If you've watched the prior part of this video, you'll know that I've been calling that current I1, and that's 4 over 100 microamps, which would give us 40 kiloohms. And then we can do the same for, sorry, that's a 1. We can do the same for R2. Now we know that there's no base current, so we know that the current in R2 will also be I1, which is 100 microamps. So we're hoping for 2 volts there. And we'll do VB essentially over I1, which is 2 upon 100 microamps, so that's going to have to be 20 kiloohms. And that only leaves us with the value for RE, and that's Ohm's law on this resistor is VE upon IE, which is the same as IC, which is 900 microamps, so 1.3 volts over 900 microamps. So that's going to be in the order of 1.15 kiloohms. I don't know exactly, I need to work it out with the calculator. 1.3 divided by 900 E minus 6. Oh yeah, I went the wrong way, didn't I? That would be more than a kiloohm would drop this down. It's 1.44 reoccurring kiloohms. Alrighty, so that will be self-consistent because we chose our currents and worked out our voltage accordingly, and then used those two to work out we chose our voltages and then we chose our currents and then we worked out our resistors accordingly. So that Ohm's law will apply to the resistors, and that will produce the answers we're after. If I decided I was feeling mean, I might pick some of the resistors and leave others, or pick some of the voltages and leave others. I might choose I1 and not choose IC or something like that. In which case you can't just apply the method blindly. You can apply the equations blindly if you want to, as long as it's this circuit. If for some reason I was feeling horrible, I inserted an extra resistor, or you came up against some situation in your engineering career where you had some other circuit that was subtly different, even a small change, the equations don't apply anymore. You have to derive some new ones which do apply. So there is no point in learning the equations. You have to learn how to put the loops on the diagram and derive them. But you won't have to derive any equations, any long sets of equations for an exam, because I don't think that's a very good test of of knowledge. So that's an example for the circuit number 2, and we could pop that in a simulator and we'd get fairly close results. Wouldn't be the same, of course, because our assumption of no base current isn't entirely true in a simulator. We'll take account of that sort of thing, but that's how it's done anyway.